Hi everybody, right? It's your logic instructor from pre-COVID-19 era, right? I'm here to work some proofs for your viewing pleasure today. These are conditional proofs. You've been assigned a few of them and I just wanted to work them to get across sort of how the setup works, and if you're having any trouble you can refer to this video and it should help you. I want to start today by working on one called 5n from Unit 8. I don't think this was assigned to you at all. If you didn't have the rule of conditional proof, this would be a difficult one, right? But because you do have it, it's quite straightforward. So part of the point with beginning here is just warming up, and part of it is because I want to show you kind of the power and the intuitiveness of this rule, conditional proof. So that's what we're going to illustrate. What are we trying to do? Well, we're trying to prove a conditional, hence the name conditional proof. You can see it's a conditional expressed over here under the conclusion, right? So if you're going to set this thing up, right, in the right way, you're going to start with that conclusion at the bottom, right? So we should just write that down. Here's our premise, it's if A then C, and here's our conclusion, if it's if A and B then C. If you just think about the logic of that, that should be provable, but it's not obvious how to prove it, right, until you've worked it out and have the rules, right? So let's try it. So we'll write down the conclusion here at the bottom. If A and B, then C. Right? Now, are we entitled to assume that we're done? No, right? What we're going to do first is note, right, that this is a goal, and we do that by writing a question mark over here. Okay, so let's go back. And this is where the setup for conditional proof matters. This is where you do the setup. Now, the most direct way to prove a conditional is by using conditional proof, and how do you set one up? Well, you set it up as a subproof inside the main line, which is what you have here, right, of your proof. So I'm going to just draw that subproof line, and you should get in the habit of doing this yourself. Then, what do? Well, I'm going to write the antecedent of the conditional that I'm trying to prove, and in this case, that's A and B, right? And then I'm going to write over here the justification for that, and that's assumption for conditional proof. So conditional proof is just making explicit that you're assuming something. You might not be entitled to it in some kind of completely general way, but you're assuming it and then you're seeing what follows from it. And you're just marking that out with these lines. That's what's happening. So what else do I need to write down? Well, I need to write down C, because what I'm going to try to do is show that if you assume A and B, then you can get to C by logic. That's the idea. Now, just to clean things up here a little bit, right? I know that I'm going to use conditional proof. That's going to be the justification for this last step, right? You don't really write a line here, but I'm writing it to show you where it goes. And I don't yet know what my reason for C is going to be, so I can put another question mark there just to tell me. Okay, so moving back again. Now I've got some pieces and I can start actually doing the logic. I can derive C given A and B. So how am I going to do that? This part should be pretty straightforward for you at this point in the course. Right? So you're going to look at this conjunction and you're immediately going to think, simplification, that's the way, right? So you're going to go A there, and right? That just means that if you've got a compound conjunction, you can have either side of it that you want. And you pick this side because you're already looking up here and you see that you're going to be able to use modus ponens here to generate what you want, right? So this is simplification on line 2, right? And then already we're done basically with the proof, right? If A, then C. What's our rule for C? Well, I just hinted, but you guys were probably on the ball, right? So you're going to put modus ponens down as the reason for that, right? And you're going to cite the line numbers, line 1 and line 3. Then the last thing you want to do is indicate, the scope of your conditional proof. So you've taken yourself back in, right, off of this subproof line. You've discharged this assumption, right? And you're just going to finish things off by citing the whole subproof. And that's lines 2 through 4 inclusive. Now, you've got a proof, right, of this sought for conclusion. Bravo! Okay, now we're going to tackle another proof. This is one you actually assigned for homework, I think. Or if you weren't, it was one that you should practice, right, as a way to set up to do your homework. So this is, I think it's 4A from Unit 9, right? So here again, we're going to try to use conditional proof, right, to get more comfortable with it. Our conclusion is written over here again. Right, so we want if A, then either E or F. That's what that says, right? And we're going to try to prove that using conditional proof. So here goes, right? We're going to write that conclusion down right at the bottom. And right, we're going to use the obvious rule here. So we've got if A, then either E or F, and we know that we're going to use conditional proof, or at least that's what we're going to try to do. So we've got a question mark there about the numbers, but that's what we're aiming for. Now, just like in the last one, you're going to set up a subproof structure, right? So you start here, you take that step in, now you've got your subproof line written down, and here's step 3. It's going to be the antecedent of that conditional that you're trying to show. So in this case, that's again A, right? And then you write down the consequent here, right, which is E or F. You don't know how you're going to get that, right? So that's the question mark. It's still a goal. What have I forgotten? Well, I've got to write premise for this, and then here I have assumption for CP, right? So just to remind you what you're doing, right? You write that down. Okay, now again, right, we've got our architecture set up, right? We're trying to get to E or F from inside the assumption A. A reminder, right, all the stuff that's outside and to the left is available for you to work with, so we're obviously going to use that. Now, some of you, right, let me just make sure you know what this is, assumption for CP, right? Some of you are probably already chomping at the bit, so I'm going to go ahead and get started, right? So at step 4, I noticed that I could use modus ponens on line 1 if I had A or B. And I've got A all by itself, and so by addition, I can get A or B, right? So I write that down, right, and then I write addition on step 3. So now I'm firing on all cylinders, right? So at step 5, I can get C. Cool, that's good, so far so good. That still doesn't give me E or F, but then looking back up here, I might begin to see what I can do next, right? So I've got C by itself. How did I get that? Well, that was modus ponens, line 1 and line 4. Now, step 6, right? I'm going to try to get this piece the same way, right? So that's C or D, right? Again, addition, right? On line 5 this time. Okay, and now I've got another modus ponens, so I'm entitled to write F down at line 7 by modus ponens again, right? That's lines 2 and line 6. 2, 6. And now, right, amazingly, I'm virtually done, right? I just have to add the E to the F, right? This is a little bit potentially confusing because you're adding the E in front, but it's the same move and you're entitled to do it. So you just write addition here on line 7. And then the last thing to do is conditional proof, right? Conditional proof, line 3 through line 8. Voila! Okay, we're back. I'm on this side of the board, and we're going to tackle the first of your homework assignments, right? So this is 4B from Unit 9. Our thought for conclusion is if C, then A, right? And we're entitled to this just one premise, right? So we're going to start here. Note that that's the premise, and then, we're going to do the obvious thing, which is go all the way to the bottom of our main line, right, and write down the conclusion, right, that we're trying to get, which in this case is a conditional. So we're going to go ahead and write conditional proof here, even though we don't know sort of how many steps or what the step numbers are going to be. So we go back up to the top, and we do the same thing that we did before, and that is to write things down like this in roughly this order. Notice this is kind of cool because we're working both ends towards the middle, right? That's one of the fun things about conditional proof. It's what gives it its power. Okay, so now we've got C. What's our reason for C? Well, it's not a premise. It's an assumption for conditional proof. So that's what we write down there. We're assuming C, and we're seeing what we can do. Now, at this point, we don't know how we're going to get A. We know we want to get A by itself, and we can sort of see that there's an A above somewhere, but we're not sure how to get it, right? So you might be, I don't know, a little mystified at this point, right? So this is a place maybe where inspiration has to strike. But if you haven't forgotten like everything by this point, if you're not completely distracted by COVID-19, right, you'll notice that you've got here the opposite of what's here, right? C and not C seem like they're opposites. That's a good thing to mean by opposite. And notice, right, you have a familiar inference rule that you can use here, namely modus tollens, right? But in order to get modus tollens, what you actually have to have is a negation of this step. And then that will give you the negation of this step. How can I get the negation of that step? I mean, I've got C. Oh, I know. I'm going to use double negation because right? Not C is logically equivalent to C, so that's just dn on step 2. So I've got not C by itself, right? And that means I've got the negation of this step, right? Which gives me the negation of this one by modus tollens. So let's do that next. So that's not, and this is where the negations start to get unmanageable, right? You've got so many squiggly lines, you don't know what to do, right? But that's modus tollens, 3 and 1. Okay, but now you're off and running, because you know a rule for driving those negation signs inwards, right? Namely, De Morgan's, right? So we're like, oh, this is going to help. We get not A all by itself eventually, and not B, right? Just in one step from 4. So that's De Morgan's on 4, right? And now, wow, fantastic, I'm nearly done, right? I can get not A by itself by simplification, our old friend that's helping us again. Simplification on 5, right? And then I've got A, right? That's just a double negation, if you like, in reverse on step 6. Double negation 6. Then all I have to do to finish the proof is note that this is step 8, right? Conditional proof 2 through 7. Bravo! Hi, I'm back over on this side of the board again. Okay, so this one is actually a homework assignment. Some people have tried to do this and turned it into me already, and it's a potentially confusing one. In fact, even the instructor's manual that came with the book, right, doesn't have a correct proof of this one. It's potentially complex, right? So I'm going to try to solve this one in a way that's going to make, I think, the most sense to you. This is a case in which we have to relax our general assumption. Our general assumption has been immediately set up a subproof structure from the bottom, right? And we're not going to do that this time. But just bear with me and I'll talk you through this proof. All right, so what we're going to do again, like always, is write down where we're trying to go. And that's if A, then C, right? That's ultimately what we're going to do, and presumably we're going to have to use conditional proof again. But for now, let's just leave that down there, right, with a question mark next to it. We're going to try to get there. And we want to draw, again, a very clear sort of main line, right? Because that's to be proved on the main line directly underneath the premises. Now, what are we going to do next? Well, this is a case where it's actually going to serve you better. It's going to be less messy and maybe less confusing, right? If you look at the top and you work from the top down first, you can kind of see, right, that if you could prove this piece here, then you could get C on the main line by itself, right? And it turns out that once you got that, it would be very easy to prove if A then C, right? So we're going to try this. We're going to try, that is, to prove first if A then B, right, as a conditional, this little piece. We're going to try to prove that on the main line somewhere so that we can use modus ponens on that first step, right? So how would we set that up? Well, we're going to do it like this. As always, you're going to sort of set in your subproof line here, right? And it's going to be assume A, or conditional proof. And now what we're going to try to do is get to C somehow, right, from that, right? I'm sorry, we're going to try to get to B from that. What we're trying to do is get to B, because what we want to do is prove this piece first. Okay, so that's just kind of a reminder. All right, so how would we do that? Well, we got A, so if we got A, then we're entitled, because all these steps are just available to you, right, because they're out and above, then we can get immediately, right, step 5, it is not the case that E or F, right? How do we get that? Modus ponens, right? Steps 4 and 2, right? And then you've got a De Morgan's there, right? So that's not E and not F by De Morgan's on 5. Okay, and now what? What are we going to do? Well, you're probably thinking, well, look, I've got a disjunction here, and I've got one side of it negated here. So I'm going to try to get that by itself first. That's not E, right, by simplification on step 6. But then I've got B, which is where I was trying to go inside this subproof, right? I've got B by disjunctive syllogism, right, on 3 and 7. So now I've proved, notice, I'm in a position to discharge this assumption, that is to go back to the main line, right, and write if A, then B, right? Okay, well, that wasn't where I was ultimately trying to go. I'm ultimately trying to go to if A, then C. So far I've proved if A, then B by itself, right? But that's perfectly fine. It's a conditional proof inside my set of assumptions, right? And right, it's specifically steps 4 through 8, so that's what I'll write down here. So far, so good. Everything's got its proper justification, and we're on the way to proving it. Now, how am I going to get that? Well, what I want to do now, notice, right, is prove if A, then C. Okay, so I'm trying to prove if A, then C, and now I've set it up as a little subproof structure here underneath this other subproof structure. Notice, this is important, none of these steps are available to me inside here, but I'm perfectly free to assume A again. And I've got my justification for that over here, assumption for conditional proof. Now what am I going to try to do? Well, it turns out I'm trying to get to C now. That's what I want to do. And this might be a little bit counterintuitive or surprising. I'm not really going to use this A, right, at all. This A that I assume just provides me the subproof structure I need to prove if A, then C. But surprisingly, I go all the way back to the top, and notice I've got my if A, then B as one piece, and I've got that proved here. And notice that that's just the first half of the conditional itself, with C, right, as the as the consequent, right? There it is. So it turns out that I'm done, right? I've got step 11, C is provable, right? It's derivable, right, from modus ponens on steps 9 and step 1, right? And then I just need a justification for this last step, but that's just, right, conditional proof, steps 10 through 11, right? Bravo! This is potentially confusing because, as I said all along, you've got two different assumptions of A, and another confusing factor, right, is that you don't really do anything with this step. There's no operations performed on it. It just sets up the structure such that you can assume, again, what you're trying to show here, right, namely this conditional. Okay, bravo! That was one of your homework assignments. I hope you find it a little clearer now.